Today we are looking at graphing equations. We're into a mini unit on graphing equations and slope. The packet you picked up, that you need to keep track of. Okay? You can notice that's a notes packet. There are 4 pages in there. We're going to do 4 days of notes, 4 days of practice, 4 days for this mini unit. It's a mini unit. Right? Normally units are anywhere between 10 and 12 days. This one's going to be 4, 4.5, or 5, depending on how things lay out, how things work out. Questions for me? A 3-hole punch that I expect you to keep track of that, and I expect you to bring it to class every day. All right, so put your name at the top of it, put your class period at the top of it, and then let's get started. So we've got some objectives. First thing we're going to do is we're going to set up how to graph linear equations. Now that's a new word for you, so we'll get some vocab here in a sec. But we're going to set up how to graph it. We're going to find ordered pairs that are solutions and make a table of values. We practiced ordered pairs last class, right, where we know what to do with an ordered pair. Ordered pair is x comma y, right? So x comma y. That's an ordered pair. Actually, I'll put it up here. I'll need it right there. And then tomorrow, we're going to graph linear equations. We're going to actually graph the equations from a table. Equations are represented, or at least linear equations are represented by lines. So yes, yesterday's homework was graphing points. Tomorrow we're going to graph lines. We're going to use points to graph lines. Okay? So you need a couple of important words. First word that we need to know is called a solution. All right? A solution is any ordered pair that makes an equation true. Any ordered pair that makes an equation true. Brendan, you'll be taking these notes with us. You don't get to sit out. So any ordered pair that makes an equation true. So when I plug into an equation, does that make a true statement or does it make a false statement? That's how we can determine if an ordered pair is a solution. Because remember, x comma y, we've seen equations with x's in them, right? We've seen equations with y's in them, and now we're going to have equations with both an x and both a y. Those are called linear equations. We're going to focus on linear equations. An equation is linear if the solution forms a line. Why does it make sense that linear equations would be an equation that forms a line? It has the word line in it. Line. So a linear equation is an equation that forms a line. What would be a nonlinear equation? Yeah, an equation that forms anything else other than a line, exactly. So we've got 2 skills that we need to do today. The first skill is figure out if a point is a solution. The second skill will be creating points that are solutions. Those are the 2 things we're going to focus on. We'll ask ourselves, is this point a solution? Is this ordered pair a solution? Meaning, does it make the equation true? And then the second half of today's notes will be, let's create our own solutions. Okay? Let's create our own ordered pairs that make the equation true. Those are the 2 things we're going to do today. So, let's start off with the easy one. Determine whether the ordered pair is a solution of this equation. Now you'll notice right away that there's an equation, y equals x plus 5. That's our equation. Y equals x plus 5. Now, keeping in mind that these are ordered pairs, number 1 is an ordered pair. What is my x in that ordered pair? 40. What's my y? 45. You guys remember what it means to substitute? When I had a substitute last week, what happened? To replace. So what we see is, what is x for this point? 40. What is y for this point? 45. So we have an equation with both an x and a y. Do you see the x? Do you see the y? There's the x. There's the y. What should I do with this x and this y? Plug it in. I'm going to substitute. Which means what? To replace. So what I'm going to do is my y value, which is 45, is going to replace the y value in the equation. So 45 equals x. Well, what's x for this point? 40 plus 5. And then I'm going to ask myself, are they equal?
Yes.
Is that equation true? It is. Why? Because 45 equals
40 plus 5.
40 plus 5. Check. So we would say, yes, that point is a solution to that equation. Why? What does the definition say for a solution? It makes the equation true. Does that point make the equation true? Yes, it does. Let's try the second one. So what's our x in that coordinate point?
21.
And our y?
27.
27. So we literally just plug it in. So 27 equals 21 plus 5. And we ask ourselves, is that true?
That's what
It is not true. Why? It's 27.
21 plus 5 equals 26.
26. So we would say no. Now, before you guys do 3, 4, and 5 independently, we're gonna do one together. Important, you must prove your answer with work, which means that we have to see that you plugged into the equation and that you simplified. Remember what simplify means? It means combine like terms. So I'm gonna do 3 with you, and then you guys are gonna do 4 and 5 independently. So when we look at this equation, now we have a new equation, y equals 3x minus 1. Notice now there's going to be some order of operations that are going to have to take place, because there's both multiplication and subtraction. So here we go. We've got our x and we've got our y. So we have 11 equals 3, and here's where I say parentheses are very, very helpful. Because what if this was a negative number? Well, then I would have to make sure that I plugged in a negative number. So you need to use parentheses when you plug in when there's multiplication or division. Use the parentheses. Whenever you plug in and there's going to be multiplication and or division, you need to use parentheses. All right, it's important. Now, order of operations tells us, and we have to ask the question, are these equal? We need to show our steps. What's our first step going to be? 3 times 4 is 12 minus 1. 11 does equal 11. So yes, this is a solution. Yes? Great. You and the people around you do number 4 and number 5. Talk about it with your neighbors. Do number 4 and number 5. Make sure you're plugging in the y for the y and the x for the x. Do not plug in 7 for y because they both come first. Plug in the x for the x and the y for the y.
Will the bigger number always be y?
No. We'll see somewhat that it won't be. That's a good observation, but when there's fractions floating around, the bigger number won't always be y. You should got no and no, right? Erasing that stuff. I think 25 or number 5 was probably pretty obvious. Questions for me? So what we're doing is we were determining, are these points solutions? Or in other words, do these points make the equation true? So we were answering yes or no, depending. So most of the time, guys, you're not going to have points that are given to you to determine if something is a solution. Typically, what we have to do is we have to find our own solutions. Okay? Typically, we have to find our own solutions. So I've provided you with a table to help set up finding solutions. And I've already provided you with the work for the first one. Okay? We need to create our own points that are solutions. Now, you may have heard this before, but the x is oftentimes called the input, and the y is oftentimes called the output. Anybody ever heard of input and output before? Good. In an equation, there is an input and an output. The input is what you plug into the equation first. The output is what you get after you simplify. So you guys have that first equation, y equals x minus 4. We want to choose 3 values and then make a table. We want to create a set of values that are solutions. Sometimes we call that a solution set. So the last column of this table, notice how it says x comma y. In that column are going to be a list of points that are true, that are solutions. This is the solution part. Right? All of these are the solutions. Over here, this is the work to find them. These are called the inputs. These are called the outputs. And this center column, this is the work. All right? So if you think about this table like that, I didn't mean to erase all that, by the way. Input. I'll just put it right back in there. I'm sorry. There. Put it all back. So what this means is we're going to be plugging in the numbers that are on the left. Now I've given you some values that are really easy to plug in. You always want to try to plug in what would make your life easier. That'll make more sense once we have some fractions. But why is 0 a really easy number to plug in? Well, you already have the work for 0. And you have y equals 0 minus 4. What's 0 minus 4 equal? Negative 4. So my output is negative 4. Because when I simplify it, when I plug in my input and I simplify, I get my output. Which gives me my first solution. What is my first solution? 0, comma, negative 4. That is a coordinate point that makes the equation true. Yes? We just found a solution. 1 is also a nice number to plug in. So let's plug it in. Okay? Y equals 1 minus 4. What's 1 minus 4? Negative 3. So negative 3 is our output, which means my coordinate point is what?
1, -3.
Perfect. 1 comma negative 3. And then my last one, I plug in y equals 2 minus 4, which is negative 2. So my output is negative 2, and my coordinate point is 2 comma negative 2. Don't forget that your input and your output create your coordinate point. This is what we're doing today. Creating solutions to equations. It will make more sense when we graph them, why this is useful. But did anybody notice anything? It's actually increasing by what? Each time. That's because the slope of this equation is 1. The slope of this equation is 1. So for every 1 increase in the input, it increased 1 in the output. Just a little preview of future lessons, because the slope is 1. It will not be the case here. It's not going to increase by 1. Anybody got an idea of what it might increase by just by looking at the table? Anybody got an idea of what it might increase by? It's okay if you don't. I was just curious if anybody had an idea. By looking at the equation, you think it's going to increase by 3 each time? Let's find out. Okay? All right, Luke, give us the first one.
Okay, y equals 3 in parentheses 0. Minus 1 equals -1.
Perfect, man. And then the y column.
-1.
Awesome. And then the xy column.
0 and -1.
0, -1. Absolutely. Outstanding. Why is 0 nice to plug in? Because no matter what you multiply by it, it's still going to be 0, right? That's why 0 is a nice number to plug in. All right, Stephen, give us the next line.
Y equals 3 in parentheses 1 minus 1, so that'd be 2. Y equals 2, so the coordinate plane would be 1, -1,
Not 1, -1.
2,
1, 2. Can you walk us through how you got 2 here?
because 1 times 3 equals 3 minus -1 equals 2.
3 minus 1 is 2. Exactly. And then, Maddie, can you walk us through the last one?
Y equals 3 parentheses 2 minus 1. And then I got 5 for that because 3 times 2 is 6 minus 1. And then it would be 2, 5.
Perfect. All right. Actually, questions on this slide. Great job, all 3 of you. Yeah.
Don't go to the next slide.
So what you're doing is you're creating a solution set. A set of points that are true for this equation. Okay? And eventually we're going to plot these and make a line. Okay? Eventually we'll plot those on a coordinate plane and make a line. Today we're not going to do that. Now, somebody asked me a question earlier and said,
Will the x always be?
will the x always be smaller than the y? It depends. It could be on this one. It ends up being bigger. But something's a little bit trickier on this one. What makes this one a little bit trickier? Yeah, and that's not going to make it harder as long as we remember what fractions do. Right? As long as we remember that fractions they're not difficult. It's just multiplication using fractions. But one thing I do want to point out is what I call the easy points, quote unquote. Notice the points over here. I picked 0, 1, and 2. Here I picked 0, 1, and 2 because those are easy points to plug in. Easy inputs. Why did I pick 0, 2, and 4 here? Why are those easy inputs? I call them, I don't really call them easy points. Usually I call them nice points. I call them nice. Why are 0, 2, and 4 nice?
Because you divide by 1/2 and half of 2 is 1.
Yeah, half of 2 is 1. Half of 4 is 2. What would be some other nice numbers that I could plug in? What would be some other nice inputs? 6. 12. 8. What do all those numbers have in common? They're all even. Why is it nice? Well, because all even numbers are divisible by what? Divisible by 2, and 1/2 of an even number is easier to do than 1/2 of an odd number, right? So these I call these nice points. And we strategically pick them so that it'll make our life easier. If you can be strategic about the inputs, your outputs will be a lot easier. A lot easier. They're nice because they're divisible by 2. All right. I want you and the people around you to try to fill out this table, and you can check your work with me. I'll give you, let's say, a minute and a half. I think you guys can get it done in 1 minute. All right. Hey Siri, set a timer for 1 minute. It didn't work. Make sure you show your work in the show work box. All right. Eyes up here real fast. Check your solutions, make sure they match mine. They should, because these are notes, and you should have the same work as me. One thing that might make this a little bit easier is this little piece right here. Maybe instead of doing just all of this in your head, maybe try simplifying the 1/2 times 2 first, and then adding the 2 separately. So you'll notice I have this separate little work here. Remember, I said this is the work column, which means you can show your work there. You don't have to do all of it in your head. I didn't. I simplified the 1/2 times 0 first, then I added the 2 to get the y. Here I simplified 1/2 of 2 to get 1, then I added 2 to get 3. Simplify 1/2 of 4 to get 2, then I added 2 to get 4. So it might be in your best interest to do that. If you are somebody who can do that in your head, then you can actually get rid of all of this. I'll show you in a moment what I mean when we draw our own table. Okay? If you are someone who is not able to do this stuff in your head, then you should draw a table that looks like the one I provided for you. All right, you should draw your own table. Nope, have the X column, the work column, the Y column, and your XY column. You should have all those. Right? And that is fine. That is great. All right? And we want to have at least 3 points. However, eventually we're going to work to what's called a T-chart. Eventually. All right? A T-chart. Anybody ever heard of a T-chart before? Sweet. It's where you have an X column and a Y column. That's it. We've actually seen these many times. We called them tables earlier. We called them tables. So this is what you're going to do. But eventually, we'll make a T-chart. A T-chart because of the structure of this. Yeah? It looks like a T. And you'll have the inputs on the left, and you'll have the outputs on the right, creating coordinate points. So eventually we'll get to that. I'm going to release you guys to do 5 and 6 in just a quick second, and then we'll come back together and talk about them. But before we do number 5 and number 6, I want you to focus on number 6. Think about it. We don't want a bunch of not nice points. What would be nice points for this one? Numbers that when I plug it into this equation are going to give me things that won't be a fraction. Saeed?
3, 6, and 9.
3, 6, and 9. In fact, I want even nicer points than that. Saeed has got us 98% of the way there. Thinking about numbers that are multiples of what? Multiples of 3. Why, Saeed, did you come up with numbers that are multiples of 3?
Because the denominator is 3.
The denominator is 3. Hey, the denominator is 3. So, nice inputs are multiples of 3. But Saeed gave us 3, 6, and 9, and I think there are even nicer numbers than 3, 6, and 9.
0, 3, 6.
Why? Why 0?
Just because it's 0 when you play,
It'll stay 0. So Saeed got us 98% of the way there, and Luke got us the rest of the way over the finish line. In my opinion, would 3, 6, and 9 work though, Saeed? Yeah. What are some other numbers that would be nice? 12, 30. 30 would be a really easy one, right?
100.
100 would not be nice. Why? Why would 100 not be nice? It's not divisible by 3. 300 would be good though. Now, would it be nice if we were actually graphing this to plug in 300 for your x value? Probably not. Would 30 be nice? Probably not on a coordinate plane, right? Typically when we graph stuff, it's usually on a 10 by 10 coordinate plane. So -3 would work. -3 would be a good number, but I like 0, 3, and 6. All right, the rest of the time is yours to get 5 and 6. I'm going to bring us back together in, let's say, 5 minutes. Try to get those done. That's plenty of time to draw your tables. Plenty of time to draw your tables. Plenty of time to fill those out. Work with the people around you. if you do finish these tables, you can start working on the homework, but we are going to talk about these tables. We are going to fill them in together. Okay? If you want to try making a T-chart, that's cool. I wouldn't yet. I wouldn't try to go that fast yet. I would stick with the tables for now. Maybe try doing T-charts tomorrow. I'd stick with the table for now. Collaborate with the people around you. Make sure you're checking each other's work. Make sure you agree. I'm going to be up here doing the same thing you're doing. Sitting down, though, because my back is killing me. So once you've got your table and you've got your X and Y's, make sure that they are in an ordered list. We gotta stop worrying about the table stuff. Making the work done. The tail is going to look perfect. Just needs to have the use of it. So, pick a number, ready to go. Why don't you start with two? You can start with two. That's fine. Zero is easier, but two is good. You don't have to start with zero. You put zero down. You gotta just do that. One of the things you got to do with your tables, guys, is you need to have an ordered pair somewhere. There needs to be an ordered pair, because that was by definition what a solution was. A coordinate point or an ordered pair that is a solution that makes the equation true. So it isn't just a bunch of numbers and a bunch of work. There needs to be a coordinate point somewhere. That's why that last column is the x comma y column. It's the coordinate points. We got one more minute to get as much done on the notes as you can to finish up the notes. You are not to go over to the homework until you have finished those two problems on the notes. What you got going? worry about that table. You're taking too long on drawing the box. Don't worry about drawing the box. Just start doing the work on the box. Okay, good. All right, good. Those points are good. Keep in mind the goal of this is to eventually put these points on a coordinate plane. So if you find yourself getting input and output numbers that are really big, hopefully tomorrow you'll recognize, oh, I need to pick different numbers, but for today I'm okay because I'm just making the points. Tomorrow I'll need to make different numbers. Don't forget we can plug in negatives, and tomorrow we will have to. Tomorrow we will plug in negatives in order to graph. But for now we didn't really need to. These are the two tables that I made. As we don't need to be packing up, we still have 3 minutes left of class, so stop packing up. 3 minutes of class is about 4%. It's like 6% of class, so still plenty of time. Notice I showed all my work here. I expect to see the work. Now, eventually, you'll be able to do this. Eventually, you'll be able to get to one of these T-charts, where you'll do your work on the side and make a T-chart, where this is the X coordinate and that's the Y coordinate. That is acceptable work for not today's homework, but for future homework. Okay, today's homework, I want to see tables. I want to see the work involved. All right.